Hi, hello, this is your Lucky sir. We'll go with thermodynamics theory part. So this is class 1, you can say. What is thermodynamics? Thermodynamics is completely a experienced based concept. That means if you are touching any hot substance, you feel definitely hot. Your finger feel hot. That kind of concept. If you touch ice, you feel cold. This kind of experience. Okay, now when you touch, if anyone says ice is cold, how can you believe? If you touch, you can say, right? So this is all experience based concept. Thermodynamics is experience based concept. What we mention here, you see, the subject dealing with the quantitative relation between heat energy and other forms of energy in physico-chemical processes. Quantitative relation between heat energy and other forms of energy in physico-chemical processes is called thermodynamics. Basic definition. Then what we discuss is chemical thermodynamics. What is chemical thermodynamics? The branch of thermodynamics which deals with the study of process in which chemical energy is involved is called chemical thermodynamics. Means heat of reaction. In a chemical reaction, energy will be released or energy will be absorbed. If you are discussing about that, then that is called chemical thermodynamics. These results are formulated into 4 laws, namely zeroth law, first law, second law, and third law. These laws are based on experimental facts but not on the theoretical facts. This is most important point. They are based on the experimental facts but not on the theoretical facts. Thermodynamics predicts the energy transformations and feasibility of process. Spontaneity of a process is measured here. Means whether the reaction takes place or not, it says. But with what speed it is taking place, that is the job of chemical kinetics, not thermodynamics. So thermodynamics job is whether the reaction is possible or not, spontaneous or not. Energy transformations and feasibility of a process, it is done by thermodynamics. Thermodynamics deals heat changes occurring between system and surroundings. What is system, what is surroundings, about all the definitions we'll discuss. So what are the limitations of thermodynamics? What it cannot discuss? These laws do not give any idea about the rates of the process. With which speed the reaction is taking place, no idea. It fails to explain the systems away from the equilibrium. If it is not in the equilibrium, then again this is having some trouble. So some important terms that we are going to use here. 5 minutes class we will make. Okay, now some 10-15 units will convert this topic. First point, system. System means if I am holding this iPad, this is the system, remaining all universe is the surroundings. Okay, if you are holding a pen, pen is the system, or yourself is the system, remaining all is the universe. It is any part of universe that is under thermodynamic study at that particular instant. That is system. A crystal, a physical process, a physicist, a chemical reaction for a chemist, all this. Surroundings, the remaining part of the universe other than system is called surroundings. So universe is equal system plus surroundings. Boundary, we know about the boundary. Okay, now when batsman playing here, okay, now if he is hitting a shot, if it is falling here, that is 6 runs. If it is coming here and going, this is 4 runs. How can you decide based on this? This is what boundary. Okay, now boundary means we generally say in chemistry, in cricket it is 4. Here actually boundary means if this is surrounding, if this is system, the wall between the system and surroundings. This may be imaginary wall or a real wall. That is called boundary. Any real or imaginary rigid or non-rigid surface that separates system and surroundings is called boundary. Okay, now generally questions won't come based on this. This is all the idea. Types of system. Systems are classified on the basis of their interaction with the surroundings as well as open system. Open system means between system and surrounding there will be complete heat changes possible as well as matter also possible. That is exchange of matter is possible, heat is also possible. The system where matter and energy are exchanged with surroundings. Boundary is not sealed and not insulated. All living beings, reactants in open vessel. Easy example I will say. This is a coffee cup and you are taking a hot coffee here. what happens? After some time, this hot coffee will become cool. Yes, heat is exchanged. And if you leave like that only, after a couple of days or 3 4 days or 1 week time, that will become dry. That means matter is also exchanged. Okay, so that's called open system. Coming to closed system, the system where only the energy but not the matter is exchanged with the surroundings. Boundary is sealed but not insulated. Boundary is sealed and not insulated. Means you see a closed steel container having hot water. Now you see same, but you close this. Okay, now hot. After some time it will become cool, but matter will be there only because matter is not going anywhere because this is sealed. Okay, now sealed but not insulated. Isolated system. Isolated system means the system which does not exchange either the matter or the energy with the surroundings. Boundary is sealed as well as insulated. A perfectly insulated closed flask containing water. Now you take the same coffee in a flask for some time, for 6 hours, 12 hours like that. Okay, now if you are taking this is the flask. In this flask it is insulated as well as closed. In this case, if hot coffee is there, this will be hot for 6 hours like that. Okay, until 6 hours or 12 hours based on the flask capacity. It is, you can say till that time it is isolated system because heat is as it is, heat changes are not there. It is hot means hot only, cool means cool only. No heat changes, no matter changes. Boundary sealed and insulated. On the basis of composition, there are two types of systems: homogeneous systems and heterogeneous systems. A system consisting of one phase, pure solid or a liquid or a mixture of gases, only one type of systems. Okay, now I think one more should be here. Heterogeneous system. A system consisting of two or more phases, a solid in contact with a liquid state. Heterogeneous, homogeneous is well known to you, so we don't waste time there. We'll come to this one. State of a system. The state is defined based on the pressure, volume, temperature, right? The system is said to be in a certain state when its macroscopic properties have definite values. It is defined in terms of its state functions such as pressure, volume, temperature. Okay, now state of a system, liquid state, solid state, gaseous state, when you are saying that in terms of pressure, volume, and temperature, like that. So the system is said to be in a certain state when its macroscopic properties have definite values. If any of the state functions is changed, the state of the system is also changed. For example, you see, at 1 atmosphere pressure, water is solid below 0 degrees Celsius, liquid between 0 to 100 degrees Celsius, gas above 100 degrees Celsius. Pressure you are making constant. Now if you are saying temperature below 0, 1 atmosphere pressure below 0, that means solid state. 0 to 100, liquid state. Above 100, gaseous state. State functions are state variables. The thermodynamic properties whose values depend only upon the initial and final states of the system and are independent of the path are called state functions. For example, initial state is there E1, E2 or H1, H2. It depends only on the initial and final states, but not on the path how it is converted. Whether you are going like this or whatever the changes you are making, no worries. It depends on the initial states and final states. The thermodynamic properties whose values depend only on the initial and final states of the system are independent of the path are called state functions. If they depend on the path, they are called path functions. We'll go for that. You see these examples. E, internal energy. H, enthalpy. S, entropy. G, Gibbs energy. Pressure, volume, temperature, number of moles. Pressure, temperature, number of moles, volume, all these we are taking in gaseous state. Measurable properties. Okay, now all these are depending on states, initial and final states only. So all these you can remember except path functions means work and heat. Path functions are those which depend only on the path. Okay, now work and heat. For this, the best example is, for example, you are coming from ground state to ground level, you say floor 1 to 5th floor you are coming or 6th floor you are coming. If you are coming by the steps, it will be different. If you are coming in the lift, it is different. So state functions means floor 1, floor 5th. This difference only they are taking. The energy of you at 5th floor, the energy of you at 1st floor. That is only considered in case of state functions. In path functions, you are saying, oh, if you are coming by lift, the energy change is small. If you are coming by steps, the energy changes will be large. Because when you are coming over the steps, you will be losing more energy. So this kind of concept is known only when the path or state is dependent. Path or state are defined also. Okay, so path function means it depends on the path. Okay, now path means you remember this example only, whether you are using lift or you are using steps. In both the cases, the work done looks same. That means you are coming from 1st floor to 5th floor, but when you are coming through steps, you are working more. Okay, now so work is the path function. Work depends on the path. Thermodynamic process. Okay, now this all will make in the next class. Thank you.